right, for this example, you'll notice I took a lot of the scaffolding out of here, so I'm kind of leaving it up to you again to take what you've learned and start to figure out what has to be done. So first thing that you should do is identify those simple statements and assign them variables. So I'm going to let statement P be Ms. Peterson, and again, keep things in the affirmative, will test for her 3rd degree black belt. And my statement Q is going to be her son, again, affirmative, tests for his 3rd degree black belt. Okay. All right, so once we've got that, we're going to take our argument and we're going to write it in symbolic form, okay? So Ms. Peterson will not test for her 3rd degree black belt, so that's a not P. If and only if, so there's our double arrow. Her son does not test for his 3rd degree black belt, so that would be a not Q, okay? A little birdie told me her son is testing in 2020. So again, it has nothing to do with the little birdie, right? What are we saying here? Her son is testing in 2020. So that would be Q. And the conclusion would be, therefore, Ms. Peterson is testing for her 3rd degree black belt in 2020, which is statement P. Okay. When we write that in the form where we have the ands, we've connected those premises with ands, we would have not P, if and only if not Q, and Q implies P. So again, premise and premise implies conclusion. All right, so from here, we need to go ahead and fill out our truth table. Now there's a little bit more going on here than there have been in some of the last ones. You should have 5 columns if you worked on this, 5 additional columns beyond the P and Q to make this work. So let's start with the things in parentheses. So we need a not P column. So that's going to switch the truth values of the things in P. And we also need a not Q column, which switches the truth values of column Q. Okay, so those two are relatively simple. Then from there, I'm going to go ahead and take care of the entire statement there. So not P, if and only if not Q. Okay. So we're looking at the columns here that we just filled in, okay, those right there. And an if and only if, remember, is going to be true if and only if the values of your 2 pieces are the same. Okay, so a false and a false gives us a true, and a true and a true gives us a true. Otherwise, it doesn't. So in this case, we have a false and a false. That gives us true. A false and a true is false. A true and a false is false. And a true is true. Okay, so getting rid of my little highlighting part there. All right, so we've got that whole parentheses there on the left. The next thing that we should go ahead and do is then incorporate this and Q into the mix. Okay, so just take care of that entire left side. So not P, if and only if, not Q, and Q. Okay, so what are we looking at? We're looking at this not P, if and only if, not Q column we just did, and all the way back here to the beginning, the Q column. And remember, ands are true only when you have a true and a true. Okay, so we've got a true and a true. That gives us true. We have a false in there, so that's false. The next one, we've got a true and a false, that's false. And then we have a false and a true, that's false. Okay. Then, last but not least, get rid of my highlighting here again. All right, so last but not least, we're going to go ahead and do the entire statement. Okay, we're going to go ahead and take that entire statement, and I'm going to again use square brackets to just kind of separate it out, make it a little clearer what's going on. And then our implies P. All right, so the columns we're using are this last one that we just filled in, and our very, very first one, and again, in kind of reverse order. Remember, this part over here on the right is the if, and this is the then over here, and so we got to read right to left. So does true and true give us a true? Yes, it does. Does a false, if false, then true, give us a true? Yes. If false, then false, true. If false, then false, true. Okay, so looking at that last column, what can we conclude? We can decide that this is a valid argument.